Okay. Okay, for those who try to run the program from last week, but everything resulted in a 404 can be found. Okay, the reason came from this line in the producers in users.java. Okay. So previously between the QS and the MIME type, content type, it was a spacing. Okay, this was the original code. So if you were to put in a semicolon between the content type and the QS and republish, everything will work. Doesn't don't ask me why this so apparently when it doesn't work means everything was a 404, none of the APIs can be found, and on top of this there was no console error that will tell you what is wrong.
Until I run debug, then I saw there's this error.
Yeah. Okay. Okay. Yep. Okay, so today's objective. Okay, so yep. So today we are going to finish assignment 2. Yeah, so if you head up based on after what you did today, everything works, you should more than just pass lah. Okay, now please inject some of your own creativity inside there. So according to, let's look at the question now. So according to the question, what we've done is a lot of number 2. Okay, so there's number 1, A, B, and C, and D, and there's a bonus F. Okay, so we'll work on 1, A, B, C, and D, as well as last week we want to do basic authentication. So basic authentication, in this case, I was saying you can copy and paste from whether API or somewhere, right? So let's get into that. So once we set up the basic authentication filter, you can basically annotate your authentication the security annotation on the web services resources, so that you can decide which methods must be authenticated before it's used. So you create a class called basic authentication filter under the com.taxiapp.app namespace package. Okay. And now the copying would start. so So if you try to remember what this application class supposed to do, is that it's supposed to be inherited from something because it's authentication filter. Let's see. Okay. So authentication filters will implement this class called a container request filter. That's one of your important points here, right? And okay, so let's take a look original code for this game. So this implements a container request filter. It has an annotation called provider, and within it there are context. So when we actually need to implement this container request filter, what you are doing in Java, if you recall, is that you are overtaking that class and saying what you need it to perform. So let's see. So there will be quite a number of stuff that you actually need to import. Okay. And because you're implementing a class, you need to follow some of the class actually original methods. Yeah, so as I say, this part is a lot of copy and pasting. So first thing that it follows is that it's this thing called context, called resource info. The context, the last time I was telling you, context allows you to access information from the request. It basically tells you what method is the client trying to access, and what HTTP method, what class, what URL, and what are the parameters sent over. The filter will be the actual method that actually kind of process the incoming request before it passes on to the actual method. So this you need to do override, means you're actually writing a new implementation of it, the custom implementation. So within this part here is where you can do a lot of copying and pasting, right? Quite blindly copying and pasting. So here in the filter you get resource method. So resource info, this is the context. You get the resource method, which will tell you, okay, what is the method that the client want to access, and then it also tells you what are the annotation present. So if the client wanted to access this method inside taxi call users, say example get all users, okay, we have a get all users method, right? Now it wouldn't be nice to expose this endpoint to everybody, so this is probably one of the first endpoint I will actually put a restriction on, which will not implement. Okay, so I'll say only the admin person can get this. Okay, or I want to put a deny all. So the method here would actually be telling you which method among your resources is the client try access. Okay, and then from there it can actually tell you is there an annotation present, like a permit all, a deny all, or allow with the rows allowed. So if it's a deny all, the logic would say abort the current request and then give it back a forbidden with a message access block for all users. Now if there isn't a deny all, it continues to get the headers. So you want to remember that authorization, basic authentication will use the header called authorization, and it will be preceded with a value called basic followed by the so-called encrypted key or the encoded keys. So here we try to get the property, and then we check if the authorization property is empty or null. If it's empty, then we will throw this off back to the user. Otherwise, we'll attempt to get the username and password from this authentication header. Okay, so currently the method here uses a base64 as decode. It's not an encryption. Anyone can decode a base64. And then we'll extract the username password, which is delimited by a colon character. Okay, so at this point, line 66, you have the username password, and this is the part where you want to match with the DB. So this is the part where you're actually going to call your service method, user service, the method called authenticate. So in order to access that class method, you need to import the class. So import taxi app services user service. Okay. So somewhere here. So I guess since anyway I'm going to be actually right here, what I'm doing is I'm checking whether the username is equal to John and Wayne, right? So this is a hard-coded checking. So if I want to just check whether username password is valid, I will do it at this point. Okay, so I'll probably, when this class starts, I will do a private user service, create a new instance. Okay, so with the new instance of a user service, I can actually check. So let's see. So if, right, user service authenticate, not really if, basically sorry, I need to return a login result. Okay, so let me get a login result from user service authenticate username and password. Okay, login result, of course I need to import this guy. So here, if login result, once I get a login result from authenticate, I can come to the if statement here and say if the result is true. So if result happens to be true, false, then of course I need to block, right? So if it's not true, I would abort the request and say that you can access this resource. Okay. Else if it's true, it continues, right? So there's a part here whereby this area will check user access, right? So here we're not checking user access at all. Let's see. Return. So yep. Okay. I think that should be it. Let me take a look at the original code. So let's just check a few things, make sure that it's right. Authorization header basic, okay. Properties, get this, okay. So let's, okay, one more thing. I need this to be registered in the app. So we have authentication filter class, but we need to register inside taxi application. Come from, dot class. Okay, let's try. So let's, yes. Okay, so it's working. We know for sure it's blocked. So right. Now I want to allow certain things. Let's see. So users is blocked. Okay. One thing I do not want to block is probably this authenticate. Should we try this authenticate then? Okay. So this one needs to be allow all. So let me put a allow. Is it allow all? Yes, permit all. Not allow, permit all. Okay. So permit all. Doesn't need to have a token or anything. Okay. So this is still cannot. Okay, let me go to user authenticate, right? And yeah, this all works. So what is happening now is that I allow the authenticate method to be used by anyone. However, for the rest of the methods, like update, get one user, you have to be logged in first. Okay. Now I'm gonna try this. So get all DB users. Okay. I think this is roles allowed, right? Let's see. Roles allowed class. So there's this annotation called roles allowed. What it will help you to do is to limit the user roles that can access a method. So all users, I don't think any login user should be able to access this method. So I create a thing called roles allowed. Now, if you look at our table in users, we don't have a role yet. Okay, so maybe for the start, I'll alter this table. Okay, yeah. Some of you had this screen, right? This problem here. If it's too small, I think you need to drop this thing down. Yeah. Okay. So I'm key in a call role. Give it a varchar. Okay. Apply. Okay. So it's a simple column that will allow me to update set the role of the user. So okay, so you have everything here except for one column row. So let me just insert into users, or insert an admin kind of person. So insert users, user ID, no need that, username, password, first name, last name. Okay. Let's see, this should work. So username I call it admin, password is mail13. Okay, so we have a user inside now. Great. My wonderful app doesn't allow me to see that. Okay, so my backup.
Can you also use the Postman to post the data into the user database?
Can. Another way you can use that, because we haven't put any security yet. That's why you can do that. Okay, so let me get all users. Okay, I cannot. Let's see. Okay. So get all users. Now I will get all users, only one admin person to go in. Okay. So when I have an admin here, which is a bit different. So when I'm sending my authenticated request over, I am sending username, login and username, username and password, which is encoded. So start off by going to authorization, choose basic, and yeah. So here would be the username that I want to use. So let's say you're using John Wayne, right? Which doesn't exist. What happens? Okay. Whoa, okay, internal self error. Null pointer exception. Okay, again I know what happened. You try to look for a John, you cannot find it, and try to compare that with Wayne. Yeah, so that would have broke the app. Let's take a look at the console log. Okay, so error happened in here. Last login date not equal now. That's this. That's funny. Last login date is now here. Oh, that's because user is now. Okay. So before we do all this thing here, like checking last login date, failed login and stuff, yeah, a very important thing, user must not be now. And then you do all these things. So do you understand why I need to check if the user is not now? here result false, just say invalid user. Okay, so I look for John, but John doesn't exist. Therefore, the user coming back is null. And before I check all these things, I should, of course, handle the null exception. Okay, let's try this again. Yep. So, cannot access. John Wayne doesn't exist, so he can access. Now, let's put in Jitan. Okay, update preview request. No, so every time you change username and password in Postman, please remember to click preview request because it will encode it a new fresh one in value here again for basic. And I will send. Oh yes, so now I can see all the users, right? Okay. So currently this method get all, it has a rows allow admin, but I've not checked the admin yet. I'm just allowing anyone who has a basic correct username and password to pass through. So if I want to be really restrictive, I must make sure that the user has a correct row matching this row allowed, right? Okay. So to verify user access, this is the part that we can actually uncomment off. So there is this method called this is annotation present call rows allowed. So previously there was an annotation that checks it does it have permit permit all class and deny all. This one is the next level where I check whether there's a rows allowed class. Okay, this is what. Okay, it's complaining. Not sure why. Yeah, is annotation present? This guy. Right. So after checking if the present annotation rows allowed exists, for example in this case this method is a rows allowed, then we retrieve the annotation to find out what is the value here, this admin value. So to get that you use the get annotation, then you return you a list of annotations here, then we had to do some conversion from array to a hash string to a set of strings. Okay, and then we check the call method is user allowed. Now, so is user allowed will be a private method, I think. Yes, it's a private method. Yep. So is user allowed is will be a private method here that has returns you a boolean. So this will be a very simple method that checks if given the username and password, does that row set does a row exist in this row set. So the row set is like a list of users. Okay, so let me get a result first. So here, what you need to do is you need to actually pass in the username and password as well as the row set. Okay, and we need a user service method to handle this. Okay, so we create a new method is, so what do we call that, is user allowed. Okay, but here I'm checking user rows. Oops. User rows exist. To check user rows exist, you need 3 parameters: username, password, and the set of rows. Okay. So, have you all seen a set before, Java? No. Okay. Okay. Okay, set is very much like a list, a collection. So in general, it's a collection. It's very much like your array list, a list. Now the unique thing about set is that in an array you can have duplicates. First and second item, third item, there can be many duplicates, but in set you cannot have any duplicates at all. So set usually derived from one type of set is called hash set. Example, a perfect example of a set that you all have been using is actually JSON. Okay, so your JSON structure, JSON actually has a natural rule that it follows a set. That means your attribute cannot be repeated. Okay, so that's the meaning of a set. Some sort of a set. So the set will very much be much like this. In other languages, they call it dictionary. So every key or every value is unique. You cannot have a repeated. So if let's say a set, you try to insert a name after it got a name inside, the Java will complain that you cannot do that. So that in essence is set. So here, of course, user row exists in the service, and then I go down to the data user store, also create the same signature, the same value here. Okay. So actually, do I need to do this? User right is here. Let's see. So basically, what I need to do here in user right is I need to get a user by username and password, and then check if the rows exist inside there. So my user store, what method do I have in user store to reuse? I have a get integer, get by user ID, get by string, get all. Okay. So maybe let's have a get user by username and password. So this is get. So right now I've duplicated one of the methods, which is get with username, but it's now get with username and password. So I just change this accordingly. Add in the additional parameter, as well as set the additional parameter here. Execute everything, and then return me the object. Okay, so now one thing I'm missing from this part will be the rows, because I've modified my object here, right? I got rows, or row. So that means my user object need to change. Oops, not this one. User model. Call this row. Okay. And inside my repository, there's a different methods that I am actually retrieving data. I need to now include the row. So to be consistent, I'll do it everywhere else. Okay. So add user as well. So add user, do I want to create a row? Probably not. Okay. So here the part where you add user, I think we can decide if you want to include the row as well. So let me put the row in, just to make it simple. Set string 7. So what is the user will be based on the row supplied in the user model. Got that. Update user as well. Okay. So should I have an update user to the row? Maybe not. Okay. So this other user would be likely used by user updating a profile name and all that, but I don't want to touch the row. Yeah. Okay, so now I got that. So now here in here, so what I do is that I retrieve a user model. to the DB. So get user by username password, right? Okay. Then I check if user.row, or rather, see. So in Java, if you have a set, they have some method to check whether it contains. So if this contains the user row, okay, whether we just return the result of this. Okay. Now, let's see. A few things happen. Check if user not equal to null first. Okay. If it's not equal to null, then return the result of this, whether it contains a row. Else, return false. Okay. So get user by username password. If this combination exists, the user, then you check the rows. Else you return the false. So when checking the row, if a row contains this set contains the user's row, then of course that will be true. Otherwise, be false. So now go back to basic authentication filter. Okay, so here I just need to hook up to user service dot user row exists. Okay, so I'll pass in username, password, and the row set parameters. Okay, and then I use this method here. So technically, if user is allowed based on their username, password, and the row set, and here will definitely return. If it's not allowed, you return you can access. Otherwise, it will continue. Okay. So let's look at the database again. So in the database, we have this few users, and I'm going to modify the admin, give it a role called admin. Okay. Everyone else has no role. Let's leave it null or empty first. Okay. So technically, so what happens is that if currently Jitan wants to access this method called get all users, he's not an admin. Okay, because his role set doesn't contain the admin. Yep, it should be denied. Right. So let's try that. Yeah, publish. Yes, new publish. Okay. Yep. So Jitan cannot see all the users. Now I want to try this thing with the real admin person, admin admin123. Okay. So go back to here. Change this to admin. Okay, 123. Update the request. Okay. Send. Oh, still can't see it. Oops. Okay. See, okay, so check my database first. Row admin. So if I went in here, check user allowed, user service, user service, retrieve this, see the rows here, contain the user row. Okay, what is my row?
Is the
Case sensitive, yes, okay, case sensitive, you're right, case sensitive. Can be case sensitive. Okay, no thread. Let's do a break line. Okay, so debug mode, check what happened. No pointer exception. Oh, the old one. Okay. Okay. So now we are debugging mode. Good. So if I do this, Eclipse will be giving me a feedback soon. Okay, yep. So where did I stop? I stop here. Okay, so let's step through the code. So step over. Okay, so what is user right now? Let's take a look at user. User is admin, correct? Row is now. Oh, row is now. Okay, what happened? Database had, right? Did I do a when I do a query, did I include the row in the query or not? Oh, there's a star, right? In database. Okay. Okay, let me check here, right? Yeah, there's row there. Okay. Let me browse. So there's value. Have value, right? Okay. Let's go to debug. Call it again. Okay. So correct username and password are used in the Postman. Okay. Okay. What's the rows here? Admin. Okay. Next line. User. Row empty. Interesting, huh? Okay, so something from get user by using password didn't work. Okay. Let me turn on the site. User store. So I will get user. So the statement is select star. So I should get everything, right? Okay. Set break here, right? Okay, let's break here too. Okay, let's try. So continue. Call one more time. Okay. So let's see. So step over. Set the statement. Execute the query. Okay. So then next the result, right? So this is the result value. Okay. A lot of stuff inside. Move it to next. Okay. How do I see the data inside results? Fields. Okay. 7 fields, huh? Last field here. Okay. Database name now. Connection. Coding buffer. Okay, let me find something that I can at least recognize. Let's see, because it's all really hard to read through. No. Row data. Okay. Rows. Just use the model. Yes. Yeah. So here I get string. Okay, we could mix this smaller. So user model is here, right? Okay, not yet, not yet. I'm only at get user. So username nothing, right? Okay. Now username has something now. Okay, set user ID. Okay, password something. Set user ID something. Set the field login count. Okay, field login count value. Get last field login date now. Gem. It became out. Yep. Okay, so before I come here, right here there was error. Okay, let's print the stack trace. Actually, we got a lot of missing print stack traces here. Okay. So other than if I were to put this beforehand, there's a real bug lah. There's a real bug. This part here. Okay. Get string date time and then store in here. That's a problem. But we don't know what's the problem. Okay. So let's restart now. Okay. So let's call this again. Okay. Okay. Wrong one. To ex. Print the wrong. Okay. Now we see something coming out from all the stack trace. Null pointer exception. Okay. Where did null pointer exception happen? It happened here. Okay, so when I get string last field login date as a string, the problem with this is that for the new user, it's on now. Okay. So how do we fix this? Well, very simple. Before doing this, or before converting this thing, so basically let's store the string first. Okay. Last field, just call last field login date string equals to. So let me get back the value, because if it's a null, it will store the null inside here. Okay, so I don't need this one here. But I need to check if this one is not equal to null. Then I do the date conversion. Else, leave it as it is, because it's only been null. Okay, so still keep it as per normal. Okay, so let me see, are there other places that I get the data? Yeah, I do. Let's change this. Yeah. Can probably change the way I set this one. Okay, so quite a number of places to update. So let's continue execution. See, check this again. Okay, now we go to a breakpoint. Let's see the same thing. We clear this one. Let's see the same thing will happen again. Okay. So my user row is populated. Last part return, no error. Postman gets the response. Okay, so unless you are an admin with the right password, then you can call this method get all users. If you were John Wayne, if it doesn't exist, you won't get anything. And if you're any other users in the system without an admin role, you can't call the method. So this is how you do the roles on top of your basic checking.
So for assignment 2, we do it this way can already.
This way is good enough. So the rows one is extra lah. Okay. So now, so since our authentication framework is set up already, final step is actually just to go through the different methods here and decide who can access what. For example, adding users. Rows allowed, only admin can do this. Okay. So get users. Okay. So because I set the other users as a row empty string, yeah. Do you think it's okay to have a row empty string here? Do you think it's okay if I have an empty string row for all the other methods? So long as you are a user, you can access it.
No, should be permit all.
If I permit all, then everyone in the world can access it.
Oh.
Yeah.
Oh, that means you can only see your own details,
Yes.
but not the rest. Oh, okay. So rows allowed blank.
Do you think blank is a good idea? Since the rest of the rows here is not there. Or it's clearer to have a user. Okay, so in practice outside, normally for rows we have a very clear definition. So leaving it blank is not necessarily the best idea. So normally we do have a row for every user up to guests, or guests also we also have a row sometimes. Yeah, but that's to facilitate like maybe tracking and such. So one rule of thumb is whenever you have rows, never leave it blank. Even if it's the least privileged user, you still have a name. Because a lot of times when you have something that's blank, tend to have more problems.
Then how do we control it such that they only can see retrieve their own data and amend their own data?
That one you have to control at the code level in the logic
Android,
wise.
the app.
In the web service. Yep. So let's say I get ID right. Who can do this? Admin can do this. So let's say admin the person. Admin can do everything. Okay. So let's see. Supposed to do admin user.
More than one row.
Yes, correct. So admin is like the one who can do everything. The part when you want to only allow the user to access their own, right? And access their own user pickup location. Okay, as well as if there is one more method we create to update their profile, right? So they cannot update other people's profile. You cannot do it. So you can't do it at using the rows allowed area, but you can do it when you are in the user service. Okay. So let's see. Okay, so a few places I can do it. One place I can do it is within here, the web service here. I can get the headers, just like how the authentication filter extracted the username and password out. Okay, that's one place. And then I do a matching. Does this equal to the ID that's provided or not? So there's some kind of validation as well as here user ID. So as long as I have a user ID, and every time the person is sending me always includes the username and password, I can always do a query to counter check if it is at the own user name. So if it's the own user, then I can allow the update to go through. Otherwise, I can kick them out. So you can do it at this level here. Okay. If you were to do it in the user service level, okay, there are some code changes you need to do. Okay, for example, like get. You need to probably provide additional parameters to decide whether you're gonna get or not. Yeah. So like it's like saying, so who is asking for it? What kind of user? And then you can maybe say requester username, right? I don't need a password, just a username good enough. So the requester username is actually its own user itself. Like example, Jitan, right? He's updating user ID 7. So again, if I can make these two matches from database, then I allow. If let's say he's trying to make update to user ID number 2, then I don't allow. So where you do that will be likely, if you do in a user service, then you need to have this parameter to do checking. If you don't want to have the parameter here, then you do the checking in your resource here. So before I do a get, I'll probably write pseudocode. Retrieve requester user compare with ID. And compare ID. Okay. So if match continue, else return maybe a 403 forbidden. So this kind of very micro level of checking is the part where the framework the library doesn't check automatically for you. You have to actually write all the check and balance in the code itself. Yeah. So this is one. So this is users. Now authentication is done. Then we move on to I think our main highlight is done. Okay. Add taxi location. Okay. So add taxi location, get taxi probability, and then estimated waiting time by date and time, next 5 as location. So 4 methods to create, and all will be finished before you go back home. Okay. So taxi location, right? So taxi location will naturally be a resource. So let's start with a resource first. So under resources, I'll care taxi location, taxi locations, and inside taxi locations, I will designate the path for taxi, maybe taxis. Okay. So here all taxi locations. Yeah. Okay. Now in this, based on the question, you need 1, 2, 3, 4 methods here from question part 1. So we'll write the methods to retrieve those. So public response. So what's the first method? Add location, right? So add location, you probably need to have a taxi model somewhere. Okay, similar to how add users or add user pickup location. Turn response, okay. Okay. Do add taxi location model. Okay. Next one, response. So get appearance probability. Okay. So get appearance probability at location in next 30 minutes. So there are 2 parameters, location, which is my longitude, my latitude, as well as minutes. Okay. So we return a response. So this one will most likely return object. Return a list. No, actually return an object or number. In this case, maybe we just return a number. Okay. For get estimated waiting time, so get estimated waiting time based on location. So you have location and date and time. So this one is there, but the third parameter would be basically a date. Now the date here, okay, so we will use yeah, I think the SQL date. Okay, next one, get next 5 best locations. Set the response first. So get next best locations from the current location of area radius. So it needs to have a current location and then an area radius. So again, double longitude, latitude, current location, and then radius. So radius will probably be meters. So these are the 4 methods, and now we start defining the path and the post and put. So for add, we will be doing a post. It most likely consumes an application JSON. Okay, no path. Okay. Now for this one, it will be a get. Since it's going to return a single number, then I don't need to set anything. That does have a few query strings and options here. So let's see. So here what I'll have is, for each of them I can create this annotation called a query. Oops, it's my query param. Okay, so a query parameter tells me what value from the query string to bind from. Okay. So for longitude, I'll be looking for this keyword in the query string, which is a question mark longitude equals something. For latitude, it'd be this value. Okay. And for minutes, okay, it'd be this. Okay, so we need to import our stuff. So very much the rest of them are all the same, using the same get method. Yeah. So the rest of here won't have any post methods. And same thing, you have a number of these query parameters to set up in the annotation. Is there anything missing here? Oh, what? The date, right? Radius is a type of integer. Yeah, this one also. Okay, yeah. Okay, so now, so later we need to come back and revisit this. So we start from the bottom again, at the repository. So create a new taxi location store. So in the taxi location store, it will be quite similar to your user store and such. Let's see, we have our SQL imports. Okay, this guy. So it's a very much a one-to-one mapping. So everything I have need here, each of them will have one method in taxi location store, like add and such. So let's do the add first. It's here. So let's see. I think what do I used to do? I used to have a get connection inside. Okay, so this is to add. So the add method here, what the add method does is allow LTA or another external party to send data into your API. So that's the basic thing of adding. Okay. So let's do an empty method first. What do I need to do? Yeah, I need to create connection. So this is okay, try catch. So here you do a try catch, of course, very similar to all this thing here is going on. Same thing again, you need a prepared statement inside here, but the prepared statement would be different because now we're doing users. So insert into taxi. So let's look at our structure for taxi. So taxi movement data has 4 columns. ID of course we ignore because we're gonna generate itself. So insert into taxi movement data. Okay, and then what are the values? So inserting longitude, latitude, and of course track date time. Okay. So in the add portion, see. So very similar to how our pickup location store or user when you do an add as such. So here we're always passing in a model. So let's go to the model to create our taxi location model. So taxi location model would follow the flow, the same columns here, except one thing is we'll probably exclude the ID because unless you want to delete by ID, but in case we don't. So what I'll do is let me create the other values. Okay. So here. So the model we'll pass in is this. Import. Oh, here is a set double. Okay, so bear in mind because longitude and latitude is a double type, so instead of using set string, set integer, you should do a set double based on the type. Okay. And this one, yes, the date time problem. Okay, so let's go to the store. Okay, so our date time. Let's see, we need to do the conversion, right? Okay. So when adding in set date, okay. Okay, so what do I do? I have a date time version conversion format, then I format it and then do a set string. Okay, so I'll just copy the snippet. Okay. So instead of this, so what I'm going to do, So it's a user locate date. I will do a taxi location dot track date time. Okay, sorry, let me change the typo here. Okay. Okay, so this is my ad. So add taxi location in the store would be as such, and then I can go to my services. Do I need services? No. Okay. Yes, I need services. So now I'm done with the taxi model. I have SQL database site done. Create a service. And here I will refer to the store. Taxi location store. See, taxi location store. Okay, so need to import this guy, and then add in the function for adding a taxi. So here we add, we can send in a taxi. Okay. Taxi location model. And then we'll call the store.add. So there's no logic here, just passing the data in. Then we'll go to the taxi location resource. So here, since we're going to have a actual taxi location model, we can use it as a parameter. So internally, I will have the service. Here, I'll do the service add. Yeah, taxi location in. This one, just make sure I import it. Okay. So that's my taxi allocation method. Okay. So far clear? Now I was doing the import of the data earlier on. So yeah, so a lot of you in the taxi movement data, if you import just one day, you have about 4 million, yeah, 4.5 million records in one table. I think the first time I see so much data in one table, right? Okay, yeah. So now the next part. So you have this thing called get probability at a location and get estimated waiting time at a location, get next best location, right? Okay. So let's see, let's go with get appearance probability. Okay, so one thing to know. Okay, to get a probability from this table, okay, if you were to try to run a query in this table of 4.5 million records to, let's say, extract some records, it's probably not that bad. Okay, so let's see. So this is data, taxis in one place, right? Okay. I'm going to try a query to get some taxis around over here. Okay. So if you're curious, how do you get longitude and latitude from Google Maps? You can do it by opening Google Maps, and then it will try to detect where you are. Then you see the two numbers on top. So there's an add number at 1.31 something something, comma 103. Now that is your coordinates. Okay, so let's copy this coordinate. So minus the z, don't need the z, just need this part. So Google Maps will tell you your current coordinates based on in a browser like this. If you were to try to pin a place, let's say I want to here, okay, I double click, then you change the coordinates again. Yeah. So this is a new set of coordinates here. Okay. So take note that this time it's got a comma 16z. Don't need the z there. Okay. Yeah. So based on the coordinate I copied just now, let's try something. It's my okay. Okay. So these are my coordinates. 1.31, 103. So 1.31 is your latitude, 103 is your longitude. So Google will give you the values latitude, longitude, but what you store right now inside there is longitude, latitude. Okay, roughly how do you know you're right? Okay, so generally Singapore is at 1.2 something to 1.3 plus to 103 point something. So that's a general coordinate of Singapore on the map. Now in terms of precision, right? If you wanted, okay, where are there sometimes more digits or less digits here? Okay. Okay. So this is a precision. Now the decimal degree precision, right, goes like this. If there are 5 degrees decimal places, right, the precision is down to 1.1 meter precise. Okay. If there are 6 decimal places, then it's down to 111. Okay, let me go to the GIS Exchange. Okay, first decimal place, okay, better clear. First decimal place gives you precision of 11 kilometers square area. Second decimal place is 1 kilometer. Third decimal place is 100 meters. Fourth decimal place is 11 meters. Fifth decimal place is 1 meter. That means, so this will tell you how precise. For example, this coordinate 103,652, and this. So there's 3 decimal places for longitude, and there is 5 decimal places for latitude. Okay. So generally for latitude, 5 decimal places is precision of 1 meter. But you have 3 decimal places here, like this. Okay, is precise to 100 meters. So there's so this are falling under this GIS, Global Geographic Information System. So they tell you about how you measure coordinates and how you use the numbers. Okay. So in order to calculate something on the fly here, because you need to do some calculations, it will be very difficult. Okay, because there's 4.5 million records for one day. So imagine you have actually 30 days, right? With 4.5 million times 30, that's 100 over million records in the table. Okay, so what's the best strategy for actually calculating probability estimated waiting time at a location? So it's not possible to have every coordinate here calculate a estimated waiting time. Possible, but it will take very long. Okay, so depending on how powerful your server is, let's say I want to calculate for this position, right? This precise position, what is the estimated waiting time? Then I have to compare with other precise positions to find out if there are any other taxis that appear at this point. Okay. So if you want to try that now, let's try this. Let's say I just copy this one up. Okay. So then I want to select from here where latitude equals to that value, and latitude equals to this value. Okay, so coordinates is such that it's very hard to have two objects sitting on the exact same spot. Yeah, it's called chance. Yeah, so if you were to try to find taxis that appear at this exact coordinate, you will probably only find one guy. Okay, so therefore that's why we have the position part in play. No. So why do we have? So the moment you reduce the decimal places, for example, here I have 5 decimal places here and then 5 decimal places on the other one, or 6 or 5. If I reduce by 1 decimal place, I can actually get more taxis in range. So that will be how you try to make it easier to find taxis in maybe a 10 meter radius to 100 meter or 100 meter square area. Sort of like a square area. So if I were to change this inline, this SQL, so it's not saying that longitude equals to 103 this and latitude equals to this. I want to find with minus 1 decimal place. Okay. Now the thing is that if I just take away 1, right, it won't work straight away. So what I will the thing is in numbers anyway. So I'll make use of what numbers do best. Range more than less than. So I'll say. So I want to find out if latitude is more than equals to this. Okay. And is change it to 9 less than this one. Then for latitude, instead of taking a 2, I take 7. So this will be more than equal to this, and latitude is less than equals to the same value, but 7 increased to 8. Okay. So now I try to find taxis that come out there. Okay. So still don't have more results. Okay, why then? So this is how many? 4 decimal precision, right? So what's 4 decimal precision?
Such a 100 meter.
This is 10 meters. So 100 meters. So this where this taxi is, right, there's no other taxi that is near it in the 10 meter range. Okay, so let's make it tidier. So now I reduce one more, 9, and then I go to 288. Here instead of 9, I start at 4. Oh, sorry. Stop at 5. So yeah, start at 5. Then start at 4. Now. So we've expanded the range from 10 meter to 100 meters box up. And now we have this list of taxis up here. How many? 14. Oh, 15 total. So the area of the number of taxis in now not 10 meter square but 100 meter square is 15 taxis. So when we're going to calculate estimated or chance of a taxi appearing, I think maybe I left it to quite loosely to define what is chance. So we can say chance is okay. Chance can be say in simply said percentages. Percentages don't mean something very useful to a person. You tell a person, oh, chance of you getting a taxi is 20%, but that doesn't mean anything, right? Not useful. But if you tell a person in the next 5 minutes, 3 taxis will pass by your area, okay, get a better sense than 20%. So probability here, we can improve the output by changing, firstly, the percentage to something like number of taxis passing by in next minutes. That's one way of expressing it. The actual calculation will be another obstacle to another problem to look at. Okay. So now that we know that within 100 meters of this particular coordinate, you have so many taxis, right? So just now what we told was just take the coordinate of one of the taxis, and from the taxi, how when you spread it out, how many taxis can you find? You get this result. Okay. So you look at the timing here. So anyway, this is in the 1 day of data. So I'm not loaded different days yet. Not too bad. 4.5 million records, you take 0.6 seconds to execute. Quite decent. Okay. Now the timing here is interesting to look at. So you have, so right now it's a bit scattered. So let me order it. Okay, so in SQL you have this function, this statement called order by. Order is like sorting. So I order by track time in ascending order. Okay. So in ascending order here, so I have a taxi that appeared on the first. Okay, remember the data was crossover from the first day. But let's look at the second one. 1 a.m., 5 a.m., 6 a.m., 8 a.m. Okay, 10, 11, 12, 14, 15, 15, 15, 15. Okay, so quickly, when you look at this quickly, right, you realize that there's a pattern. Most taxis come out at within 2 or at 3 o'clock onwards. So that means if you're trying to wait for a taxi at times like 7 a.m. in the morning or 9, I think your chances of getting a taxi is very low. But if you'll be waiting at this spot for a taxi at this time, 3 o'clock, chances are high. So what we're going through right now is looking at the data and deciding how better to actually write the logic for the first endpoint where you say get appearance probability. So first we started a very innocent idea of percentages. Then we realized if we tell someone percentage, it doesn't work. Then we think about, maybe we brainstorm a bit, say think of number of taxi passing by in the next X minutes. Sounds more interesting. But when we look at the data, is it actually feasible to get the number of taxi passing by? So roughly you can say so. You can see that here, I can tell you that there's a 5 taxis in this 1 hour block, assuming 3 to 4. Oh, actually 6 taxis. But if you were standing at a spot between 8 o'clock to 9 o'clock, you'll probably get 2. So then now is the part where we realize that time plays another part in giving you probability, time of the day. Okay. So I know for sure I have this data, longitude, latitude. Okay. Minutes, next X minutes, I can use that to my advantage based on this. And do I need to know the time of the user? Probably I don't need to, because I can get directly from the server time. So your endpoint doesn't need to send a time specifically over yet. Okay. Now if you were doing this app for as an app that caters to international audience, so users from Singapore, users from maybe Ukraine or Russia using the app, right? Then you cannot use the server time. You need to take into account another factor. When the request come in, time zone. What's the user's time zone? Then you use that to adjust the timing. So let's say I have this coordinates and the user say next 1 hour, 60 minutes. And the time right now is 1500. Then I'll take the coordinates, expand the range, so I get a larger number of taxis spread, and then take the time as a filter. So time now 1500, between 1500 to 1600. The result will be this 6 records here. Now 6 records here will give me indication, but then I need to tell the user that, oh, the 6 taxis your chance you get 6 taxis in the 100-meter area of where you are. So that's some sort of information that user may find useful. Okay. So I can use the same method and apply and get the rest of the data. So this is one way of interpreting probability. Not necessarily the best way or the right way. So you all can have your own ideas how you interpret probability. So far, I haven't gone down to creating a index table yet for this. So we're just using what we have in the 4.5 million records. Now it's easy to write this query, but harder to maintain. So I'm just one person querying this 4.5 million records, right? It takes 5 seconds, 0.5 seconds. Now you have 100 people doing this at the same time. This 0.5 may actually increase by a fair bit. Okay, so that's when the next strategy of designing a table comes in. You create another table to give you pre-calculated values for this table. Yeah. Now when you do that, it's easy on your back end, but you may also reduce a bit of the user experience. So if I were to pre-calculate these things based on timing, time slots, 1 hour blocks, right? And then based on certain locations only. So I kind of cover 100% all location. I cover approximately every 100-meter block in Singapore. So that means in Singapore, instead of having 4.5 million points, maybe I'll have about a few 100,000 points. So that idea means there's less records to query, but it's not as precise for the user compared to if the user can adjust the range. The timing blocks also play another part. The user may be limited to choosing in blocks of 1 hour instead of 5 minutes, because I only in sort of pre-calculate everything based on hourly. Okay, so let's just imagine I actually index the whole thing and I'll create a new table that's focused on returning the user this appearance probability, right? So the table would consist of the area blocks. So if I search by a longitude and latitude, it needs to match to an area to give me a certain number, but also on top of that the time. So the time will have in one day 24 slots, 24-hour slots. So per area, 24 records. So if in Singapore there are, but let's say in Singapore we manage to map about 100,000 of these plots. That's 100,000 times 24 records. Okay, which actually needs to be updated every day when we get fresh data. Okay. So if I were to create a table, it would look like, let me create a new table, see what happens. So the new table I'll create, okay, because I have my ID and all that. So what I will need to have is, first the lead hour block. So hour block will be 1 to 24. Okay. Second would be start long. So this will define the range of the plot. And of course, yeah, I need to add more. Add 2 more columns. Okay. So start latitude and latitude. So these four areas will define the area of the plot. And then when I query, it's easier to just find a match within here, plus hour block. So what are the type? For hour block integer, start will be double. The rest of the coordinates will all be double. Okay, save it. Oh, yeah, table name. So table name, taxi, area, time, probability. Okay. Actually, maybe not call probability. Time count. Ah yes, forgot one more column missing. What happened? Okay. Taxi area count. Okay, so ID. Increment. Our block. Oh, okay. So fast. Yeah, I miss out one more column. Add one more column first. Okay. Taxi count. Okay, so this table will tell me within the area in that time, how many taxis are there. Why? Because I don't want to query the big 4.5 million or 120 million record table here. Okay. So what's happening is that there can be some kind of a server-side job or script that will actually take the data from the day, compile it into this table here. Now, because this table doesn't store the date, so what it's going to do is going to take the previous result and mix it with the new result. So let's say, imagine now if I were to take account of a particular plot area, which happens to be this result here, right? So this range that I define. So imagine if this range is one plot or one square, okay. Total there are 15 taxis that appeared. Then I split it further by time. So this 1 hour block, one taxi. In between 0, 0, 0, another hour block, one taxi, two taxis, one taxi, and so forth. Okay. The next day, if I do this query again on the next day's data, okay, I may get a different set of numbers here. So what is going to happen is that, let's say for any time of the day, maybe between 3 to 4, there were 6 here. And the next day, the values come in, there were 7. Okay, so what should I do with the numbers? Okay, yep, average. Simplest way is average. So I take a daily average. So let me modify the structure a bit. So taxi count here, what I can do. So what are we trying to track here is an average number of taxis appearing in that time of the day. In that time of day, in that area. So here we have average taxi count. So every day as we get new numbers in, we actually do an average again. So it changes as the data goes by more. The so-called data, everyday data goes in. So this is one way of looking at it. Not the best way I emphasize again, because what we lose here is trending. Although we always refresh every day, but you can't tell on the past few days how's the number been jumping. Okay, if you want to tell how the number been jumping, what we will have in this table is another column called date. The denominator, number of days, yeah. So probability is itself not it's too abstract a term to use in actual fact So looking at it practically, so instead of giving a probability, I don't divide by anything. I just say how many taxis are there in this area. Yeah, if I do give you a 30% chance of taxi, you'll be asking 30% in time, 30% in space. Yeah. So in light of that, it's difficult to calculate, give a very meaningful probability. So instead of that, we say average number of taxis in that area would be more meaningful. Per minute. The movement was extracted per minute.
So in the block actually, the same taxi in this minute will also appear in the next minute. So
yeah.
So the count
correct.
Actually not really a unique count
not unique count. It's passing through. Yes. So when I think about if a taxi stays in the area, like 100 by 100 square meter, right, for a long time, right, and number one, and also bearing that in mind, every taxi in the database is a valid as a for hire taxi. Okay, so it means if a taxi hangs in your area no longer, the chances of getting it should be higher. At least I think. So if every minute the taxi count is always high, right? Even if it's the same taxi or another taxi, right? It just means that it's like a bit like density. The more density of taxis in the area is higher. So therefore the chance of you getting one should be in principle higher. Yeah. Okay lah, another example lah. If in this classroom there were 10 of us having flu, right? Chicken pox. It's a high chance of getting it, right? Compared to one person at one corner. Okay, so yeah, so that's the idea. Okay, so when we refresh the data, then we always have a way to let's say average out which also suddenly I thought of one thing, how to average out, because we need to divide by the number of days, right? Okay, yeah. Actually, it's okay lah. So divide by 2. Every time it pop up, you divide by 2. Take the number here and the new number, divide by 2. So very rough average. So this will be the table for getting the data for this guy. Okay. Okay. So here's a fairly troublesome part. Every time I create a new table, because the way we're doing this, we probably need to create a new model. Okay. Yeah. So that is a straightforward way of doing it, but we can spend a lot of effort for each table, right? Okay. So I'm going to expand a little bit more. Okay. So based around the concept of dividing the area by blocks. So dividing area by blocks becomes an anchor to how we're going to do the rest of the methods. For example, getting estimated waiting time. Now, because we don't have ability to go to so minute per point and calculating by blocks, right? Estimating waiting time will also be by block. So if you take the same principle by block, what's the estimated waiting time? Now, then can we actually, then if you're looking at that, then can we actually reuse the same table to store one more column for average waiting time? Okay, so let's look at the data again now. This popular 3 o'clock timing, right? Okay, so if you happen to be at this area at 3 o'clock, there are 6 taxis, each appearing at 14 minutes, 23, 26, 45, registered. They're there. Whether or not they just appear but they're there. So does it make sense to take the time interval between this and give you the average? Between this 14 minutes to 23, say that's 9 minutes, 3 minutes, and then 9 minutes. And then take a flat average across. Very blunt lah. Super blunt lah. Okay. So 993 divided by 3, right? That's the so-called estimated waiting time. 3 numbers, 7 minutes. So we're trying to say that if you were to be at this area at 3 o'clock, your average waiting time is 7 minutes within the hour. But if you happen to be at this area at 1 a.m., don't know why you're doing that 1 a.m., and you need one taxi, how do we calculate average? How do we calculate waiting time? Okay, so
If you look at this table, yes, but if you look at the entire records, then you're not.
Yeah.
I think got to remove that from assignment 2.
Okay. Well, at least I'm not marking how well you give me the algorithm and the logic for this part. Okay, so here's the secret of assignment 2. When you were thinking very hard about how to calculate this, right? Yes, you don't need to give me the calculation to pass it. Even if you give me a random number output from your 4 endpoints, right? Or 3 endpoints, we have how many endpoints? Probability, waiting time, next best location, right? Even if you were to give me totally random numbers from this tree, right? You will still pass making these 3 endpoints. Okay. So please don't sweat over this how it's done. However, if you want to pursue finding out how it can actually be done, go ahead and do so. Okay. It's an interesting subject to figure out how it's done, but it's not going to give you more marks for completing the question itself. Okay. Because at the end of the day, you could be taking a library from somewhere and then just inputting the values and then giving an output. So if you take a library, I cannot fault you by saying it's not your work, right? So it's pointless for me to try to mark that part. So anyway, this is called web services, not called data science.
So we can assume that we load this information in from somewhere else.
Yes. You can assume you load the information from a source, or you actually pre-compute the values into a table, you store it. Yeah. So like how I was designing the storage of it, it doesn't need to follow that way, because you may look at, maybe you have a little different approach to looking at calculating probability, waiting time, and location. So now, if I skip the part of thinking about how to calculate all the numbers, right? How will you give me random numbers? If you are very lazy, you will just give me random numbers from this point here. Okay, which will still work. Okay, so why I won't really bother with whether or not this part you write the SQL to get the data, because you already done so in pick up location and users. At least you pick up locations. You can have done the update, select, and delete. Update, select statements. That's what delete statements also have, right? Yeah. So you have done all the CRUD, create, retrieve, update, delete statements, which is good enough. So that's why for this one, you can literally random math random number return me lah. Okay. Relief? Okay. Anyone know how to do math random in Java? Random number, generating random numbers in Java. No. Basic Java. Okay, usually it falls under the math object. Normally it's static. So there's a thing called random, then just return number. So do you want me to skip the figuring out how to calculate the taxi waiting time here and go to complete the assignment 2 here? The pro and con lah. So if I were to complete the coding for assignment 2 at this point right here, right, you will have technically finished point 1 and 2, except for the bonus one, F. The F1, I leave it to your imagination now. So basically, F you do your own. Okay. If I finish this earlier, right, I will go through cheat sheet. Yeah. Depend on what you want to look for. This one? Calculation. For F.
I mean, you don't need to go through, I don't think no time. When you upload this, then try and play around.
Okay.
Play around.
Okay. So, do you want to fill in the blanks yourself on the random numbers? Because every time we go through this as well as homework, right? The last week's homework was the basic authentication. So I'm not sure whether you all did or not lah. So looking at the face, probably not lah. Okay. So this week's homework is fill in the random numbers lah. Okay. Because there's 3 numbers here, I don't even need to be JSON. Right. Okay lah, except for the last one lah. Next best locations, that one JSON lah. A list lah. Or coordinates lah. Okay.
New table, we need to add in the models and also get the pickup.
Okay, question F is similar to this one, just a bit more extra data inside. Okay, I shouldn't say give me random numbers here. It's random coordinates. Then question 2F, give me some random coordinates with random numbers inside. Okay, that's homework. Okay, do you want to go to cheat sheet? Okay, I better make sure I don't flash the test paper out in the screen. To accident lah. Jialat already. Okay. How the video first? A lot of video here. Okay. Let's see, mock test. Anybody try? Download already. How? How do you find it? Never try must try leh. Oh, similar. Like the first page similar lah. First page similar. How many questions? 13 questions, right? Okay. Okay, it is similar lah. So questions like this, definition questions. There's solution hello. No need to record lah. There's solution file here, hello. Okay. Okay, format is simple. In your test, there will be 35 questions in section A, and then section B, there will be 4 questions. Section A is all MCQ. 2 marks each. Then section B, structured questions, complete the sentence, complete the code, or list out some things. Okay, so your MCQ, what I will ask will be definition, like how do you define web services? Choose 1 out of 4. It's the correct definition. Who has the right answer for this? In the test, there will only be 1 correct answer lah. Anyone? Which one? D. Anyone else? Okay, who says A? Who says B? Anyone for C? C, no idea. Okay, good. D? Okay, correct answer is A. Yes, a solution sheet, you can download and see that. Okay. Okay, so where do you get the answer from? This sounds very easy, the slides. The slide have those keywords, mostly coupled, stateless, abstracted, and well-known communication. So a lot of the key will come from the slide. So make sure you read your slides and then understand those keywords. Okay. So if I give you nonsense like this, wait for mobile to communicate, right? Don't trust it lah. Trust whatever comes from slide. Okay. Number 2. So this is another kind of question. Quite a number of this kind. I will give you a HTTP call, like post, get, put, delete something, and then you need to tell me among the 4 options which one describes this the most accurately. Yes, I'm still recording. Okay, so this kind you will have at least 3 or 4 of them appear. Yeah, because you got post, put, delete, get, so I can play around the combination. Your query string also, path parameter. So, who says A?
Post A.
Yes, very easy.
Yes.
Because you see post already, the rest all to qualify.
Yeah, I don't need to see the rest.
Okay, number 3. I will also give you the response. Just now was a request, right? Now go do the other way, response. So which is the correct response object with pagination? Which one?
Pagination.
Yes. B? Eliminate lah. Pagination mah, so eliminate those without page one. Then you left those with page. Then the next keyword, the next thing is each page return two result. B lah, right? Okay, easy, right? Okay. There will also be questions on SQL. SQL. There are two types, data manipulation and data definition. Two main categories. So you must really identify which statement is a data manipulation or a data definition statement. SQL also can have quite a number of questions. SQL itself got also 4 or 5 questions. Data manipulation. Just tell me what is the answer. Or which are the answers. Hmm? Oh, okay. Okay, so to be very clear, SQL so the keyword is data manipulation. So of course I'm asking on SQL. So which of the following is SQL data manipulation type?
Oh, data manipulation language DML. What is a DML statement?
Yeah. So which statement is a DML type of statement? In SQL there are only two types, right? DDL and DML.
Select artist, insert into
Which one? Who says A? Anyone say A? Hmm? A.
A.
Okay.
A.
Okay. Actually A and B here.
Yeah, I was just thinking. So can you say A and B can have multiple
Only for the mock lah.
Oh,
For the actual test there will only be one correct answer. Here I'm just testing you lah. Okay. Mock. Okay. Next one. A bit of Java code, but very important class libraries you need to know. Especially when you need to use a database. So you're running, this snippet is running a paging query to MySQL database. Complete the code at line 2. I'm getting data, but I got 2 parameters on the statement.
D.
D. Who says D? Anyone A? A? Anybody? Anyone for B? Or C? Or D? D. Okay, D is the correct answer, set integer. So why are we doing set integer? Here you have a SQL query, select star from movies, limit question mark question mark. So the moment first thing you see is this is a prepared statement. Second thing, prepared statement in your query always use question mark for setting parameters. Setting parameters will always use this methods called set methods. So it generally called set method because the type is also important. Are you setting a string, double, integer, string, date time, date, or whichever? So here, limit is a parameter for paging which allows only integers. So you need to use a set integer method to set the page. Okay. This one is
limit is a keyword.
Limit is keyword also. Because you limit only accepts two parameters and they're integers.
Integers. Because I assume its page is an integer, so it's an integer.
Oh, okay.
So it's
Yeah. So if you look at the parameter or the SQL query. Okay, this one is free giveaway, like free give like that. Number 6. So XML. You know which one is XML, right? Yeah. A. A? C? No. C? Yes? Who say A? Correct answer is C. XML. Okay, very, very important. Know the difference between XML and JSON. And sometimes I may even ask, is this JSON structure correct or not? Okay. A is JSON. B is form data. Okay, B is form data. There are two types. The D, right, is the regular type of form data. Normally we call it key value pair. B we call is another type of form data. We call it form multipart. Form multipart because the type of form data allows the client to upload a file. Whereas D, the last one, that kind of form data, only text and values, text and strings and numbers. So B I showed before, I think uploading files or something like that. Okay, number 7. Sorry. What happens when this resource method is called? Also free. Yes? Delete? Yes, delete. Delete, yes. Okay, this one is called free give. Free give. Counting. Okay, number 8. What is the value can be obtained from this header? X tracking ID in the following request. I'm looking for a HTTP header called X tracking ID. Can you tell me the value for X tracking ID? A, B, C, or D? Which one? D? Okay, so this one goes back to your understanding of HTTP headers. Your headers in a request and response. When you're transmitting data through headers, how do you identify the value to get based on the header key? So X tracking ID is a header key. First thing is which is the header? Which is a HTTP header in this request? The things after here. These are the headers. And then you always be header followed by value. Header value. Now you're looking for X dash tracking ID, right? So you'll be this one. X. Yeah. Don't confuse with the other one with underscore. Okay? So this is your header. Header is after this. Now if you want to change the question and ask what is the query string, then you'll be this thing after the question mark. Okay, number 9. Basic question. What is the difference between basic authentication and OAuth? Between the four items, 4 choices. C. Who say C? Yes, C is correct. D is closed except I purposely type the change variable into O off. But class is C. So basic authentication uses an encoded username and password for each request. OAuth uses access token for subsequent requests after successful authentication. So this is the key difference between basic and OAuth. 10. What happens when a GET request is sent with a JSON body? You can try in Postman now. Yeah, okay. You always kena on Postman, you do get an answer. Okay, yes. Better not allowed. C is the answer for this one. Okay, so now okay, real life, so real life. Sometimes D is the answer in real life. It depends. This one depends a lot on how the server is configured to accept the request coming in. Yeah. So it may be a C, but sometimes it also be a D. Congratulations, you finished section A. Okay.
Pass.
Yeah, most of it.
More than 5 can get.
Okay, section B, 2 questions. First question, you're developing an API that allows a third-party app to access the user data on their behalf. To allow a third-party app to integrate securely without exposing username and passwords, you need to implement OAuth 2. Describe the steps, what credential, tokens, and describe the token structure and endpoint necessary to achieve this. Okay, this one is more difficult than the actual test question. because I learned after a few batches, I'm not supposed to give students this kind of question and then give you one big piece of A4 to give an answer. You'll write three pages for me to read. Story, So because of that, I will structure the question into a few parts. First part is describe the OAuth steps. Second part is list down the credential and tokens used. Okay. Third part of the question, I will ask you to maybe describe what is a JWT. The 3 parts of the JWT. The last part, I will maybe give you 4 tables, fill in the blanks for get data, update data, add data, and delete data. So imagine you got this question split into 4 different parts. The part that I give you the table to fill in the blanks, right, is probably worth 20 marks. Each table 5 marks. So make sure you get that one correct. That one also the easiest. The hardest one among this probably is remembering what are the steps in OAuth 2. So OAuth 2 steps, refer to slides. Where to get the OAuth steps from? Okay, so you go to your slides.
Under lesson 8.
Okay. This is the basic OAuth flow. 2 is done. So last time when I give the students one question like this, describe me the flow, and a big space, they'll draw me the diagram. Okay, more or less we'll get it right. Most of the time should be full marks by drawing me the diagram. If I simplify the question by asking me OAuth, I will ask things like, okay, generally list down the 6 steps, give you 6 lines to write. Sometimes the MCQ, I can also ask questions like, what are the different entities or different things involved, like client, resource owner, authorization server, resource server. Okay. Possible question can also be what type of tokens will be used during your OAuth. Okay, access token, one. Mainly access token is one of them. So remembering the flow is fairly important generally. You understand at least how the thing works. So if you were to actually implement OAuth, you can actually know roughly how to get the job, get the thing started. Okay, so okay. Number 2 question will be similar to the last part. Okay. So it's designing APIs. So it's like doing assignment 1, except you got 4 questions only. Okay, you'll be provided with a table to fill in the blanks. The blanks will be structured in a way that I will ask you, okay, what is the HTTP method to use? What's the endpoint URL? So that will show me the resource. And then what are the requests? Is there a request body? Is there a response after you call the endpoint? In this version, you don't care about authentication. No need to tell me what authentication you want to use inside there. So it's simpler. Okay. In terms of what data you want to send in the endpoint, up to you. You can make it as simple as possible. Okay. So generally, these are the kind of questions that will encounter in the test. Now, the cheat sheet. There's a cheat sheet. Okay. The cheat sheet is meant to help you quickly refer to some of the key information that you need to understand when you're okay, looking at the whole thing. So here it goes. Okay. Okay, this is one cheat sheet you cannot bring to this exam. I know, they give you one A4, right? Then the limitation is one A4. Then you squeeze as much thing in one A4. Very small font, right until please. Okay, you cannot bring to the exam. So this is more like a cheat sheet for developers. Okay, developers have a cheat sheet, but it's more like a reference card. Why? Because the normal documentation, they will write an essay, but we don't care about the essay, we just want the points. So we condense into a point form. So like point form in this case is definition of the level, the 4-level API, what it means. Or point form will be like, okay, a sample request like this, I color code the different parts, and then the definition of each part. Or methods, the verbs, what does each of the verbs do? So I think some you're all very good idea, yeah? Status codes, sometimes quite useful when you're debugging, and then you realize you encounter a code you never seen before. Okay. Or you can Google them when you're doing intro work you Google not like exam you cannot Google. Okay. How to secure API, what each of the authentication means in essence. OAuth2, what are the components? So when I ask what are the components of OAuth2, this column will be referring to that. And what each component does. Here, continue from the OAuth2. Okay. Of course, the flow, very important, that's why I'm putting here. JWT, components of JWT. Header, payload, signature. So for sure, I will ask something about JWT. Normally, what are the components? So this is general one of the cheat sheet for web services. I realize no SQL inside here. Okay. Last part. Okay, last part. Very important. Remember the logic for locking a user account after fail login 3 times, right? Okay. This logic here So this logic here is quite important to know the steps. Okay, when to check, do what. Okay. Refer to user service.java line method login method authenticate line 36 onwards to line 94. Okay. So in the test, there will be a few questions that ask you to write actual Java code. I will not penalize if you if you mix up the cases, like if you put capital I to small I lah. That one doesn't matter. But at least you have the gist, main gist there. It works out. But don't give me your main gist as in like how to say for example, this line, right? If user.failed login count more than equal 3, do this, right? Don't translate this 4 line into one English sentence. Okay. So coding is like breaking down an English sentence into different parts. Yeah. So something like that. Okay. I think I mentioned before about databases, right? Like connection statement, result set, prepared statement. Okay. Yeah, all these are important. You may also be asked to write one SQL statement somewhere, yeah. But simple lah, not very complicated. Okay, so rest of the time, what do you want to do? Do you want to try to complete your coding part for the assignment too? On your own here or go back home? Oh, wait for me to complete first, yes.
Work together.
We're gonna connect. Work together. Either work together and go towards the other part. Like this data thing here. Okay. See what can we do? Okay, should I do a nice one of this or give me random number type? Okay. A proper way of doing this will be having 4 the different methods here for that. Okay. So this is like get appearance probability, right? So how do I return? Okay, sorry, I'll go back to the table again. Okay. Okay, so I'll tell you how I'm gonna design. So I'll tell you how I'm going to design this thing based on the 3 questions here. Okay. So probability is number of taxis passing by, or number of taxis within geographical. Okay. In return average number of taxis within a geographical plot in our block. estimated waiting time, how I will actually do it properly is to return the average time interval between taxis within geographical plot in an hour block of the day. Next best locations. Okay. Here maybe I'll add one more query parameter. Count. So instead of having, so that we can specify that I want 5, 4, or 10, right? Do that. But in terms of the value, right? So return next, return top count geographical plots in descending order of two things. So because before that we have number of taxis within a plot followed by estimated waiting time. So I will probably give average number of taxis followed by the average time interval. Since I have this data and this data, I return the block, the geographical block, right, based on average number of taxi each block and time interval, the descending order. Why am I doing this and linking up the three together? The more easier to maintain. So instead of creating multiple tables for each use case, I'm using the same table based on the principle of geographical plots, which is a square area. So within the square area, average number of taxi, average time interval between taxis is like this. So the answers will be stored in this so-called pre-calculated table, which I can change anytime I want. So now I have average taxi count here. I will also add one more column to store a pre-calculated value for average time interval. Let's add one column here. So I call it average time interval. Here, put something integer. So average time interval I will store in seconds. Okay, then maybe the app time-wise can do a conversion to minutes and seconds. Yeah, so since now the structure of this is coming more or less to shape, maybe we can rename the table to call it, instead of average taxi area time count, what I'll do is I'll rename the table. Let's see how do I rename the table? Okay. So rename the table. Now I call it taxi area stats. Why? Because I'm collecting information in an area. Okay. So assuming this contains all my data, now I'm going to create one single model to retrieve data from here. So this would follow the structure for taxi area stats based on the columns. I purposely omitted out the ID here because ID in the case to your application or the end user will not be useful at all. So that one they don't need it. Here I will create the method for getting this one. Okay, so expand that window. So this is get appearance probability, so called. Maybe we should rename this so something more context to what we did in the table. So here we get average taxi count by area. So the area will have a start longitude and longitude, start longitude, and that's it. Okay. Then I'll have a double return quite average taxi count. Set to 0 first, return this value. Okay. Within here with the direct SQL call. So you realize here in terms of the business logic, in here there's not much because what is really happening is that business logic already pre-calculated all the stuff and throw into this table here. Okay. So you don't need to write the script to do that calculation yet. Okay. So here I will need to call a repository method as well. So taxi. So same exercise as the rest of the classes there. Taxi area, stats, store. So here you need to get me pretty much this guy. Okay, so prepare a statement. Okay. What's the SQL? This one. Okay, so what do I need to do here is to do all the parameter stuff. Okay. So it'll be different. So now instead of taxi movement, I'm calling from taxi area stats. Okay, where start is more than this value and okay, so n is more than equal. See, start single value 1 point. My point is more than this. This is less than this. start is less than this, and my current point and end is less. Sorry. Start at the tube. Okay. So we and okay. Set. Double 1 2 sorry, shouldn't be this. Actually, it's just one value, right? Because I already pre-calculated the plot. Should be one value actually. Okay, so by right should be one value, not two. Means actually it's just because user provide one value. Correct, right?
Means the usual pickup location, then that like that is
The coordinates. User will only supply one coordinate, so I need to find which plot that this coordinate land on. Okay, so it need to be one coordinate. So here we only be needing one coordinate to compare which plot I'm in. Okay. Yeah. Let's do some more. Time. So time got two lah. How many minutes later? How many minutes ahead? And then what's the so-called the current your user's time? Okay. So here use server time. Okay. Here minutes. So what is minutes? This is the next how many minutes? Let's see. Next minutes. So in the store, I'm comparing by the coordinates. I also need to compare by one more thing. And time. Okay. Hour of day. Hour of day. Okay. So this one going back to where the table is. Forgot one more item. One more column, which is the hour block. Yeah, forgot one hour block. So this is our block. Okay. And our block. Let's go to this. Okay. So my table has three inputs, the coordinate and the hour of day. Then I return the average number. Okay. So here I will return the exact column called average taxi count. result set rs equal to stmt.execute query. Okay. So if rs.next then I set result equal to rs.get double what? Oh, don't use that guy. Put okay, bye. Make sure finish the rest of it. Yeah. Got video recording. Okay. I told you already what, here you can return me random number. Okay. Okay, so if I were to combine all the data I need in one table, so basically every query based on the area they're in and the time of the hour, I will refer to the table and return the result. So is the easy part. The hard part is generating is taking the data every day and updating this on a daily basis. That's the harder part. Because in the project I'm in, right, they have daily jobs run the server every day, and someone's monitoring it every day, because it will fail. The project I'm doing, they're dealing with 1 million records a day. Yeah, they do that's for one module alone, not including the other stuff. So there's a high tendency that it will fail. Then you check why fail. So that's average taxi count by area. Oh yeah, so I need to return it to the top. Okay, so the service, so I need to do average. Okay, so the service here is a bit different, right? So the user can specify minutes. Okay, so first of all, use the time. Okay, so get hour of day starts from what? Okay, or whether all day is 1 to 24, right? We also have next minutes period. Okay, so if the user is asking for, well, maybe let's just standardize. Next minutes is always 60 minutes, 1 hour. Here I will get integer hour of day be equal to get the time again. I always forget how to get the user time properly. New date. No. Okay. New date instant. Okay. Oops. So this interesting function called new date get hours. Okay, get hours is deprecated by new util. Hours here. Oh, again. Calendar get our day. Okay. Java util calendar. Okay, now different now. They recommend new things. Okay. Okay, oh, that's easy. Hour of day. So what does hour of day return me? Let's see, 24 o'clock. Example. Okay. That means it's 0 to 23. Yep. Okay, so 0 to 3. So that means we need to store in 0 to 23 rather than 1. So here, let me get average. Okay. So what we're going to do with next minutes period. So if the user asks for 2 hours, right, that means, okay, so here you need to think a bit about how your app will actually provide this input. Okay, so if user were to be at a location and want to find out the number of taxis in that area, and they did get a specific time, like looking in the future, how would you put it? How would you phrase it in the app? Would you think of it useful as a user say, now for the next 60 minutes or 60 minutes later, or can be both for next duration now to how many, right? Okay. So this one, right? So let's say the user will specify like next 60 minutes, perfect one time block 1 hour. Now but the user will specify something weird like next 45 minutes. So you cross over, right? Okay.
Yeah, but because our area statistics we do by hour block, so should we like only allow users to select by the hour?
That might be a simpler way.
So we can make such assumptions in our notes and says our web service will have somehow allowed the user more to select the hour block.
Yeah. So maybe the Android app actually return this in terms of the hour block
yeah.
instead. So per hour of day.
Yeah. So it's like I assume whatever calling, I probably have like radio buttons for them to select. Like,
The day now.
hour.
They should choose either the current hour or the another hour, right? Okay, so that actually makes simpler, right?
Yeah.
Hour of day.
Otherwise, you can measure, hey, is current time already near the end of this hour, then got to include this hour.
Yeah. More team, right? Okay, so store. So oh, taxi locations. Okay. So our store is different, right? So this is a taxi location object. I'm sharing it with the taxi location. Taxi area stat store. Okay. Stat. So I'll get the data, the result from stat store. Count, send this tree value. Okay. So done.
Yeah. Like that already better than random already.
Then you return the number. Nothing about returning one number, you don't even care about the type. Okay, the next one, time interval. So go back to the store. Now I want to retrieve by time interval. Right?
Yes.
This value based on the block. So actually everything the same.
Yeah,
Except for this return value.
Our preparation of area stats already calculated.
Yeah, already calculated already. Yes.
So we just put in.
Yeah. So average interval, right? Average time interval. Time interval. Okay. So this is a good thing about preparation lah. Once you prepare everything sweet, right? You take the data easier.
Just put all the computation data into the
So right now it's pretty much just duplicating the thing. Okay. Okay. So also switches to hour of day. If you want date, you can also. So let's say the person wants day as a whole, the whole day. Okay. Then what we do is take the 12 to 24-hour blocks, right, and do average out. So once we have calculated values, it's easier to transform data from that point. Okay. But I think that calling by day actually wouldn't make sense. Unless the other dimension, right, is they say day of the week dimension. Okay. So if you have a day of the week dimension to this data, that means there's one more column for day of the week. Then you accurate down to day of the week patterns. Okay, for now I keep it simple. Okay, then get next best by location. Basically, we need geographical plots in descending order of average number of taxi, average time interval, based on hour of the day again. Okay, now if you do hour of the day, it's quite straightforward. Right now there's a radius, and okay, I call number lah. So hour of the day would always be the standard. Okay, so the client Android will send always hour of the day, right?
Assume that this exercise will all by hour of day.
Yeah. So radius will be a bit different. Okay, so now your radius
Version 2.
version 2 app, right?
Whoever wants to do that, go under their version 2.
Okay. Counts will be just number lah, right?
But just now for the average waiting time, our return value of average waiting time, that means we need to add in during the result return response. Get average waiting time.
Or get average waiting time.
We didn't put back the response.
The result here. Okay. This one will return
we still have it hour of days. Will we be like passing back the average waiting time, the value?
the ocean.
The field to return back the value of average time interval.
Average time interval, yeah, result then return inside here.
Or is return inside here?
Yeah. When you return a single like string or number in the response, right, it will just come as a plain text. So it's not a JSON structure, because if you're just returning one value, there's no need to have a JSON structure. So return a single value is easier. So next best file location basically is a combination of these two. Choose the next 5 best plots. So service size. So this one at this level, the service will be the one, I think, getting the get area rental. Okay, so we have where the user is, and then account and hour of day. Okay. So this will mainly be a list of locations or list of plots. So let's just create.
Then we do sorted by.
Sort by. So you return, you order by the 2 columns: average waiting time, average time interval, and average taxi count. This is array. Resist. So it'll be a double. It'll be this type here, and inside the store. Okay. 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 For this one, there's something very this method will be a bit more difficult than the rest. Hmm? This table, the data, you can enter data manually, but the proper way to do this is actually to run a script to calculate the values from the big table, right? Condense it down into this table.
I was thinking of I was thinking of copying the raw data to Excel, and then you do your
Calculation that import.
yeah, after that the final data you format and put in
Also
after
can,
some
but
so
Excel
you
has
got to write another work program to go and compute. Excel
okay,
then you can play around and do your statistics or whatever.
can up to 1 million rows.
1 million, 1 million.
The limit of
So
1
just
million rows.
copy.
Some lah.
Yeah, some.
Yep. Okay. Now this one, the actual statement to return you the area's rank based on the user's location. Okay. A bit different. not as simple as checking whether
Yes.
more than less than, right? Okay. But also there's another element which is the so-called the radius. Okay, so other than radius, which is how far what you want to go, the key thing is probably count lah.
Mm.
So naturally you'll be nearest to the person first, and then how many, right? Like the nearest 10, nearest 5. I'm gonna show you something example. Okay, so okay, so you imagine every square here is a plot, a geographical plot, right? And the person is in
Also in the center.
this square, okay? And I say I want to return 5 nearest. Technically around this plot there's 1, 2, 3, 4, 5, 6, 7, 8.
9 plus 1.
9 is one, 8.
Yeah. Actually include itself also,
Include itself
right?
lah.
Oh,
Okay, include itself lah. So 9 lah. So your let's say if there is 1, 5, I take away 1 here. I got 4 more to choose. Now the 4 more to choose, where do I choose from? So so that means out of the nearby plots, if the user say I want 4, right, I will say which of the plots around here have I'll return among the 8 here, the 4 highest ones.
Mm.
Okay. Now we put everything about radius in play, right? Radius, right? Then we need to calculate another dimension that radius will extend to how many plots out. Then you calculate based on the number of plots there.
Oh.
So there's this part about calculating the plots from here around. So in order to get me the plots around this person, which is up to 8 now, okay, or the number the person requests, I need to figure out where the plots of the start and end.
Mm. So it's like whether -2 or -3 to cover the whole
Cover
area.
the
Minus plus. That
minus
means you
plus.
got to do minus and plus already, right? That means the from 2 instead of current and then the 2 is +1, right? That means now my current the start also has to be like -2, and
Yeah.
then the end also is +2.
That will be, yeah. So if you convert the person's plot as the origin then you can do a -1 here, plus, and here plus on top, minus on top. So one way is you it's kind of like orientate to the person's plot as a center, and then you need to calculate to get the rest of this. So once you know the start and end, right, that means the start and end from here. Basically here you need to know this plot here, or the corner lah. So corner will be, you know, this corner, and then you need to know this corner here, right?
Are we able to now like go into the Google and do compute by radius? Then at least we know our coordinates has to be like -1 or -2 to cover, like, because just now we computed that will be within 100 meter, right? So now we are talking about within 100 meter, that's assuming that's in the square. So that means now I got cover 200 meter and 200 meter plus and minus.
Around right? Yeah. So we need to, because we roughly, and then we need to go back to the plots because we structure data in plots in squares like that. So even with radius, right, you need to figure out cover lah. Yeah. So it's like taking your current minus 110, then take the ending of your current plus 110, then the next range, and then also the diagonal part here. Yeah. And this is only if the user requests for 9 or lesser. If the user requests for more than 9, then you will extend into this square here. So it becomes this area instead if the person requests for more than 9.
Yes. No, then I'm going to restrict.
because 300 meters is too far lah, yeah. Because if they take the total, it will be 300 meters across, right? Yeah. So a person trying to move 300 meters trying to get a taxi, that may be too much lah. Either that or with the way that we store the computer data is not by 100 meter, it's lesser by 10 meters. So there's pro and con. Like the more data you store at that level, right, yes, it's lesser than the bigger set, but it's also still it's still big lah. Because one digit there.
Yeah, never mind. I'll do a pivot of the sample group of data. Then we know whether nine how many meter visible or not. I think it's scarcely only one taxi.
Yeah,
like
correct. Nothing to see, right?
Nothing to see. So
Okay.
yeah, we've got to play around with the data. So we fill in the blanks here lah.
Yeah.
You put some notes there that we fill
Can.
in the blanks here.
I draw a box.
Draw a big box. Yeah.
I draw a box. Literally draw a
Because
box.
they are not listening, so at least oh yeah, I draw the box. And then the center is the X.
Yeah,
which is our,
center
yeah,
X.
that is then if they don't understand, then they ask you in the WhatsApp. The rest fine. That means order by average they use the few average count.
The SQL part can be average count. So you need to identify the pairs of start and end longitude latitude, right, to query, and then order by this one. So the tough part here is figuring out where's the set of start and end longitudes. Once you get that one, then the rest is easy. Okay. Okay. Yeah. Okay lah. This part is frankly this part here that get the plot run right. You all can experiment on your own to see how you want to solve this. Yeah. Because technically, if you just return in random number and it's okay already. This is for your own self. You want to find out how to get this data. Yeah. I will also try to do lah. It's okay. It's fine. Okay, let me paste the SQL for this table first.
Save the SQL for this table.
Yeah.
The table from
Yeah, so funny, not showing out here. I'll paste this table inside.
thank you.
Okay. Okay, thank you everybody. Finally over.